welcome to Project Smith Tech. Today we're going to actually compare the 9900KS compared to the 11900K, proving that the 11900K is not a waste of sand, Steve Burke. Alright, let's get into it. Before we start on the 11900K, let's just go quickly into the 9900KS first. Now, the 9th gen, don't get me wrong, was actually a good processor. Now, it does have a few faults, and let me just quickly get into that. Now, we're going to quickly cut through Cinebench R20 and R23. Alright, this is just a quick cut of what you can expect from Cinebench R20. So you can see that I'm getting 5044. Alright, now R23. Alright, 9900KS with the R23. I'll Cinebench R23, and this is about the score that you should be able to expect. Alright, now as you can see, the scores was reasonably good, and especially in the day, the CPU was not bad. But for my problems here is, for it to earn the i9 series, I would have liked it to actually have 4 memory channels, and definitely more PCIe lanes. But my biggest problem with the 9900KS is the limiting of the chip set, and basically how it's ruining my whole life. You see, these are two M.2 drives, and I'm currently running them in RAID 0. Now, unfortunately, due to the severe limitation of the chip, and we have no direct PCIe going to the actual CPU itself due to its severe shortage of PCIe lanes, these two drives are running RAID 0, has to go through the chipset, and the chipset only allows a max of 4 PCIe lanes equivalent, so it goes from the 2 drives at half speed, not the full speed that I really wanted, and with the Samsung 970 Evo Plus, on a single, should be able to handle a sequential read speed of 3.5. Let me go through the benchmarks just quickly. I'll cut the benchmarks in here. And this is the test that you can expect from the SSDs or the M.2 drive. Now, you might be thinking, oh, hang on, it's not too bad. But keep in mind that this is actually 2 in RAID 0. No, that is not a good score, and I would be complaining heaps as I return back to the actual build. And as you can see, even though despite these drives are in RAID 0, and you do get a perfect squared both read and write, or close to, it is actually the chipset that is limiting the hard drive. And so basically I can't feed this processor because of its severe limiting, and this is something that I believe Intel should have done actually a little bit better. 2 sticks of RAM, I would have liked it to actually be compatible with ECC and have 4 channels instead of 2 channels. But anyway, and that is basically the limiting factor of this. Otherwise would be a very good PC. But let me show you the 11th. Alright, now that we've done that, we take the CPU and let's build it to the motherboard. Now for the i9 1100K. Go to the CPU. Now, compared to the 9900KS, the CPU is still an 8-core CPU, still a dual channel RAM. It is quicker RAM though. I am running 3200 in this, whereas the 9900KS is just 2666. But we go to the CPU. Now we just have a quick cut of the CPU benchmarks. Okay, as you can see, 6214. Next, alright, 11900K, just in Cinebench R23, and almost as good as the Threadripper 1950X, the 16-core part back in the day. Not bad. And now, so as you can see, the CPUs are actually quite a significantly performance boost than the 9900KS, which I thought at the time was actually pretty good as well. Now let's get to more of the fun part of the CPU. The CPU, instead of the 9900KS, which is limited to 16 PCIe lanes, we've got 20 PCIe lanes. So there's 16 from the graphics card, which will be the Intel when I just get to put it in. And then we still have 4 lanes left over and that is for our M.2 drive, which will also be directly controlled by the CPU, which is a massive improvement over the 9900KS. So the extra 4 lanes at Gen 4, I might add as well. So essentially we're doubling the bandwidth compared to the 9900KS. And we have in this current configuration, we have 2 of the drives running RAID 0 to the chipset because I wanted to see if I could bottleneck the chipset. And we have 8 lanes going to this, it's the Western Digital 1500 RAID 0 card, so there's 2 M.2s in here. So these go direct to the CPU. The Gen 4. Let's just have a quick look at the hard drive benchmarks just so we know what we're talking about. Okay, this is just what you can expect from the benchmark. This one is the 2 Intel drives that are running in RAID 0. Unfortunately, it's a software RAID. I couldn't get it to RAID with the BIOS, which is disappointing, but it's fine. And these are the numbers that you'd expect. So I'm tipping that it's been throttled by the chipset. So if I had 2 Samsung drives in there, that would give me a better indication. But I'm tipping that 2 of these together should have got a bit higher. But anyway, that's fine.
as you can see with the 9900KS, they were identical, so that was definitely a chipset bottleneck. This is the Western Digital. Now I have gotten 7000 in sequential read before, and I'm clearly not getting that now, so that could be the rebar or the 4G decoding interfering with that. And this is the Samsung, the 4G 980 Pro running Gen 4, but only 4, where this is running 8 but Gen 3, and this is supposed to be running 8 Gen 3, but with the chipset bottlenecking, I'm guessing that that's what's happened here. Alrighty, and that concludes that. Alright, to test the system as if I was running it as a server, I'm going to benchmark each hard drive all at the same time. I'm just going to see what sort of load it is on the system. So this is the final benchmark. And it's perfectly fine, you can see that there's no compromise between the two. Just to be clear, this is the C drive, so this is just the 860 that I'm running. This is the RAID 0 that I'm running with the 2 Intel Optane drives. This is the Western Digital 8 lanes PCI 3, and this is the 4 lanes PCI 4. And just for the record, I have had this much higher, so I don't know what's going on with this system, but yeah. Alright, I'll see you at the end of the benchmark. And that was its total, all running, so yep, no problem. So this would have made a very good server, if only. Now, as you can see, the hard drive speeds were pretty impressive. I don't know what is going on here, because I've definitely seen faster with the X99 platform. This hard drive runs a lot faster than what I've been getting in the last systems that I've actually tried to put this in. So it is interesting. What is interesting is we still have from the RAID 0 setup that I have here, it is still being bottlenecked by the chipset. And the chipset should, these drives in theory should be actually have the sequential read speed of much faster than what we're getting. But however, this is a software RAID where I couldn't do the RAID on the motherboard. So that might have been a contributing factor here.
So the conclusion, if you upgraded from the 9900KS to the 11900K, unfortunately I don't have a 10 core 10 series, so the 10900K would have been a really interesting comparison comparing these two, but unfortunately that's the generation that I missed out on. Although I do have the 10400 in my unraid server actually, so, and that's doing a really good job. But you still got the same PCIe lane count. So if you brought the 11900K processor and you're feeling a bit bad, I wouldn't, because if I'm running a 12900K or a 13900K, and the moment that the E-core started giving me trouble, that would be the moment that I go into the BIOS and shut off the E-cores, where this is, and the way I got it set up is symmetrical cores. It's running all the same frequency on each core. I did have to go into the BIOS to actually change that, because the natural, from its actual spec, it does give 2 cores that are much stronger frequency than the other 6, which is fine, but I can change that in the BIOS anyway, and I might do a video of that going forward. But, conclusion. 11900K, none of the silliness of the E-cores, and it just works. So I'm calling this CPU of the year. Thanks, Steve.